Okay, this is part two of the 4.2 notes, and I'm changing this up just a little bit on this because, again, we're going to graph these the same way we did when we did section 4.1, okay, outside of the fact we're going to have to find the vertex first, obviously, because we're not in vertex form. So this is graphing in standard form, okay? So as we're looking here, and as you're looking, again, the equation for standard form, we've seen this before. Okay, when we were factoring, when we were solving by quadratic formula, completing the square, this is with the equation that we saw. Okay, so in order to graph in standard form, again, you have to find the vertex first. The vertex is the most important point on graphing these parabolas. So we got to find that vertex first. Again, the x value of the vertex is the opposite of b over 2a. Okay, and then to find the y value of the vertex, you simply plug in the x value you just found into the standard form equation, and then you're going to get a number out. That second number is the y value of your vertex. Now, the rest of this, steps 2 and 3, guys, you guys can cross those out because we're going to go back to the graphing shortcut sheet on how you graph these. We're not going to graph these with y-intercepts because not every time is your y-intercept going to be in your picture of your graph that you're going to have. Okay, there's going to be some times where your y-intercept is way, way off the graph. We don't have that. So this is just a fail-safe way in order to graph these no matter what. Okay, let's take a look at the first equation here. So it says, what's the graph of y equals x squared plus 2x plus 3? And like I said, we're going to graph these, and we're going to find everything that we found in section 4.1. We're going to find what are the transformations? Tell me, what's the vertex? Tell me, what's the, is it a maximum or a minimum? What's the domain? What's the range? And also this time you're going to tell me what the y-intercept is. Because if you remember, the y-intercept is always 0 and whatever c is. Okay? So we'll be able to identify the y-intercept now on these problems. All right, so let's take a look here at this first example. It says here, what's the graph of y equals x squared plus 2x plus 3? All right, well, one of the very first things I'm going to do is I'm going to identify, all right, what's my A? My A is 1. What's my B? My B is 2. And what's my C? My C is 3. Always identify your A, B, and C. Okay? So, now, I got to find the vertex. In order to find the vertex, I have to take the opposite of B all over 2A. So the opposite of B over 2 times A. Well, that is negative 2 all over 2 times 1, which negative 2 divided by positive 2 is negative 1. Okay? So negative 1 is my ordered pair. It's the first value of my ordered pair, so it's the x value. Okay, now how do I find the y value? Well, I'm going to take this negative 1 right here, and I'm going to plug it in for this x and this x. I'm going to plug it in for the x's. So, my y value is going to equal, instead of x, I have negative 1 squared plus 2 times negative 1 plus 3. Okay, and now all I have to do is simplify this. So I go through my order of operations here. Negative 1 squared, that's positive 1. 2 times negative 1 is negative 2, and then plus 3. And then now, since I have all adding and subtracting, I go from left to right. So 1 minus 2 is negative 1, and then plus 3 is positive 2. So 2 is the y value. This guy right here is the vertex. Negative 1 and positive 2. Okay? All right, so negative 1, positive 2 is my vertex. Let's go and let's graph that point. So let's graph this thing now. Okay, so negative 1, positive 2. That tells me I'm going to go left 1, and I'm going to go up 2, put a dot, just like so. Okay, now, going back to the graphing shortcuts, if you remember right, okay, my A value is 1. So I'm going to go right 1, up 1 times A. Right 1, up 3 times A. And then right 1, up 5 times A. And my A value is 1. So in this case, I'm going to go up, or excuse me, right 1, and then I'm going to go up 1, because 1 times 1 is 1. Then I'm going to go right 1, I'm going to go up 3, because 3 times 1 is 3. And then I'm going to go right 1 and up 5. Again, the right 1 up 5 you may or may not have on your graph. Okay, so you may or may not have on your graph. And now you reflect those points. We're going to reflect those points to the other side. So I go left 1 up 1, left 1 up 3, and left 1 up 5, like so. And now you can draw your parabola. Try the best here to draw this curve. Not very good because my stylus isn't great. But you'll notice it's not it's a curve, even though it shouldn't have shaky lines like that. But it's a curve. It's not a straight. These are not straight lines, so it's not a V. Okay, I know it looks like it comes to somewhat of a sharp point, but it really doesn't. Okay, now things that I'm going to have to identify. Let's start with, what are my transformations? Okay, well, my vertex tells me my transformations to start. My transformations. I moved left 1. I moved up 2. Those are the 2 important parts. Okay, left 1, up 2. Now, my A value is 1. So I didn't stretch, I didn't compress at all. Okay, and in other words, there's no other movement. So my transformations are simply put are left 1 and up 2. My domain goes from negative infinity to positive infinity. Again, from left to right, left arrow, right arrow, negative infinity to positive infinity. My range, how low does it go? Well, the lowest it goes is positive 2 on the y-axis. So you'll notice right here, positive 2 on the y-axis. This is as low as it goes. And then it goes all the way up to positive infinity. This guy has a minimum. It has a low point. And where's that low point located at? Well, it's always at the vertex. So negative 1, 2. It's a minimum at negative 1, 2. All right, the y-intercept. The y-intercept is always, in standard form, is always the ordered pair 0 and c. Well, in this case, c is 3. And you'll notice, if you look at your graph, right there is where it crosses the y-axis, and that's the ordered pair 0, 3. Okay, so this one was a fairly easy one to graph. Again, these are not overly complicated to graph. If you can find the vertex, the graphing part is fairly easy to do once you get the hang of it. Okay, I'm going to change up this second example. All right, so the example I had before didn't work out real great, and I want to be able to give you an example number-wise that's going to relatively give us a decent number. So change your second example to this guy, and then we're going to graph this guy, and we're going to tell us our transformations. But in order to graph, got to find the vertex again. Find the vertex. I'm taking the opposite of b over 2a, which in this case, a is negative 2, b is 4, and c is negative 5. So this problem is going to be a little bit different because my a value is not 1 this time. Okay, so the opposite of b over 2a. I want the opposite of b, that's negative 4, over 2 times a, which is negative 2, which this is negative 4 over negative 4, which should be positive 1. That's the x value of my vertex. And now I'm going to take this negative 1, or excuse me, this positive 1, and I'm going to plug it in for x. So y equals negative 2 times 1 squared plus 4 times 1 and minus 5. So order of operations tells me I have to do parentheses or exponents first. So this is going to be negative 2 times 1 plus 4 times 1 minus 5. And now I can do my multiplication. That's negative 2 plus 4 minus 5. And now I'm adding and subtracting, so I have to go left to right. Negative 2 and 4 is positive 2. minus 5 is negative 3. So 1, negative 3 is my vertex. Okay, 1, negative 3 is my vertex. All right, now let's go to graphing this thing. So 1, negative 3, I'm going to go right 1, I'm going to go down 3, and put a dot. 1, negative 3, put a dot right there. Okay, now this time my A value is negative 2. So I'm going to go right 1 and down 1 times A. Well, 1 times negative 2 is negative 2. So I'm going to go right 1 and down 2. Then I'm going to go right 1 and down 3 times A. Well, 3 times negative 2 is negative 6. So I'm going to go right 1 and I'm going to go down 6 spots, just like so. And now you'll notice I can't go right 1 and down 5 times A. 5 times A would be negative 10. I'm out of spots. And then, so now I reflect this guy across, just like so. And now I can draw our curve, just like so. Okay, now, got to talk about transformations. Transformations, what are our transformations on this guy? Well, look at the vertex. The first number tells me we're going right 1, and we went down 3. Okay, right 1, down 3, that's what the vertex tells me. Then, this thing is also facing down. That's a transformation. How do you know it's facing down? Because your A value is a negative number. Okay, my A value is a negative number. Also, my A value is bigger than 1. Okay, so we are also stretching this thing. Okay, so there's a lot of transformations on this example. We moved it right 1, we moved it down 3, we faced it down, and we stretched it out. Okay, domain. Again, domain, negative infinity to positive infinity, from left to right. You guys are going to find out, actually, the more you do this, that a lot of times domain is always going to be negative infinity to positive infinity because our parabolas are going to be always facing up and down. They'll never be facing right and left. Range. Okay. How low does it go? Well, it goes from negative infinity all the way up to positive 3. So you'll notice on here, it goes from negative infinity low all the way up to to negative 3, not positive 3. I'll change it here in a second. Negative 3 on the y-axis, and then it goes back down. So from negative infinity to negative 3. This has a maximum. So it has a high point. What's the high point at? Well, the high point is at 1, negative 3, which happens to be the vertex. And the y-intercept is the ordered pair 0 and, in this case, C, and our C is negative 5. And again, if you look, we go to the y-axis. Where does it cross the y-axis? Right here. Well, that's the ordered pair, 0, negative 5. Okay, so now you should be able to complete the 4.2 practice A problems. And you want to make sure, again, I've got the assignment and then I've got a separate piece of graph paper. You'll have to duplicate the graph paper to fill out all your problems. And then you're going to describe, once you graph them, all these transformations, the domain, the range, the min-max, and the y-intercept.